I'm Carl Anthony with AutoSens TV. AutoSens Detroit 2019 here at the Michigan Science Center, well underway, and we're speaking today with Beat Decoy, the CEO and founder of ESPROS, and it's so wonderful that you've joined us here this year at AutoSens.
Thank you very much. Glad to be here.
So tell us a little bit about ESPROS. You started the company. Tell us the story behind ESPROS.
Well, when you do 3D time-of-flight imaging, you need imager technology which is very sensitive in the near infrared and which is also very fast because you're measuring the arrival time of light in, let's say, picosecond or several picosecond resolution. And unfortunately, silicon by nature is not very sensitive for near infrared. And we address these 2 points with a novel semiconductor technology. It's basically CMOS and based on silicon, and it allows a very high quantum efficiency, a very high speed and high performance CCD, ideal for time-of-flight imaging.
You have some displays here at AutoSens for the attendees to see. You have some demonstrations. Tell us a little bit about those.
Yeah, when you, as I said, we are basically a semiconductor company. We manufacture these imager chips, but there's not much to show. So it's just a piece of silicon. It looks like a processor or a memory or so. But to make that a little bit more transparent, we have some demonstrator camera modules like this one, which is shown here at our display, and it shows the performance of this technology. Basically, very low intensity illumination, but very long range.
And so, why is long range? Why is that important for this technology?
Well, when you're looking about autonomous driving or driver assistance systems, automatic parking technology, you need imagers which are capable to sense the environment in 3D, and it is any environment. So that means you could have full sunlight on your target or black night, and with a not sensitive technology, you need a lot of illumination to do this, and then you're running into an eye safety problem. So the more sensitive the receiver is, the less illumination you need, less power, but also not critical for eye safety.
So as CEO of the company, tell us about your team and some of the experts and engineers that you have working for you.
Yeah, we have basically 4 areas of engineering we do. Besides manufacturing, we are production companies nowadays, where we produce millions of chips per year, tens of millions of chips per year. And it all starts with semiconductor technology experts. So they are typically applied physics engineers. All of them are PhDs, of course. And then we do chip design, analog and digital chip design. We have a big team in Switzerland and a fairly good team in Shanghai, where we design the chips. Then there is we call that the product engineering team, which does the evaluation, characterization of the chips, but also implements modules like this. And finally, process engineers, because this semiconductor manufacturing needs specific processes. And we have people which are experts in doing semiconductor processing.
One more time, I'd like to go back to the time of flight. For those who are not maybe as familiar with it, what is time of flight and why is it important?
Well, time of flight is a technology which allows to capture 3D images of the scenery. That means with a single shot, you not just get black and white information or grayscale information or color information, but at the same time, every pixel reports also the distance to the object. So and that allows this three-dimensional imaging. And there are several techniques possible: stereo camera, structured light, and time of flight is basically a technology where you emit light, modulated light or pulsed light, and you measure how long it takes for the light to travel to the scenery and back to the camera. So, and that needs ultra fast receivers because it's the speed of light is so fast.
Talk to me a little bit about your products and services and your customers and how you're a leader in the market.
Yeah, our products are TOF imagers. We have a range of standard products, TOF imaging, so very low resolution, but also extremely low cost. For example, for people counting or just basic distance ranging. Then a little bit higher resolution like this. It's 160 by 60 pixel. These kind of products are used in mobile robotics to navigate or help the robot to navigate in the scenery, doing SLAM.
Sure.
And also automotive, for example, identify the driver or looking at the position of the driver or the passengers.
Sure.
Yeah, and then our flagship product is a QVGA imager with fairly high resolution, for example, used in automotive applications. Left behind objects is the topic here.
Beert, from all of us here at AutoSens Detroit, we want to thank you for being part of the conference. We want to wish you a safe flight home, and thank you for being here, and we look forward to seeing you in Hong Kong in 2020.
Thank you very much, Carl. It was a pleasure talking to you. Thank you.
Likewise, and speaking today with Beert de Kooi, the CEO and founder of ESPROS. For more AutoSens, like, subscribe, and share.